Okay, hello everyone. I welcome you all in our lecture series on conversion of numbers from one system to another. In this lecture series, we are discussing these topics, which are essential for your BSc, BTech, MSc, MTech, and various entrance examinations. In our last 6 classes, already we have been discussed these topics. Lecture 1, 2, 3, 4, 5, 6. Up to this much already we have been discussed. In this class, we are going to discuss decimal to BCD, that is your binary coded decimal code conversion. Okay, so let us start. So these topics already have been discussed in our previous classes. Binary to octal, octal to binary, decimal to hexadecimal, hexadecimal to decimal. In detail we have been discussed. Okay. Last class we have been discussed hexadecimal to binary and binary to hexadecimal. Okay. In detail we have been discussed. In this class, we are going to discuss decimal to BCD, that is your binary coded decimal code conversion. Okay, how we are going to do that here? Already we have been remembered these things. That suppose we are going to consider 2 is our decimal number, corresponding binary number can be represented in this format 0, 0, 1, 0. 15, if I am going to consider 15, it is represented as 1, 1, 1, 1. 14, 1, 1, 1, 0. These things already we have been discussed, right? Now, BCD or binary coded decimal code, how it will be? See here, you just follow this number 12. 12 have 2-digit number. One, this is your 1 and another number is your 2. 1, this 1 can be represented by 4-bit binary number, this one 0001. 2 number represented by 4-bit binary number as 0010. So hence for 1 we have to write 4-bit binary number, for 2 we have to write 4-bit binary number. So here for 12 the BCD code will be 0001 0010. So this is the BCD code of this decimal number 12, but it's a binary number is your 1100. Like that, consider 15. 15 has 2 numbers, so 1, if I'm going to convert to binary, it is represented as 0001, and for 5 0101. So this is the BCD representation of 15, but its corresponding binary is this one, right? We are going to consider some other examples here. Suppose we have 1897 number, decimal number. So what will be its BCD number? See here, 1 will be written as what? 0001. Here I written. Okay, 8 will be written as 1000. Here 1000. Then 9 will be written as 1001. 1001. 7 will be written as 0111. 0111. Okay, so this is whole. This is that means we have to write 0001 1 000 1 001 0111 BCD. That means here 1897 decimal converted to BCD, right? Like this, the representation will be like this. Okay, then BCD to decimal, just you have to consider the reverse step. Here a given BCD number is this one 0011 0100 0111 1001, right? So here we have to just write its corresponding decimal number by grouping 4. Already it has been given here. This one, this value is your here, this value 1001 1001 is belongs to 9. You have to write 9. Then 0,111 is nothing but 7. You have to write 7. Then 0,100. 0,100 is your what? 4. You have to write 4. Then 0,011 is nothing but 3. Hence, this BCD number converted to decimal as your 3479. Okay. So in this way, you have to convert any decimal number to BCD and any BCD number to decimal, right? Yes. Here we completed our lecture series. Go through all the videos and prepare for your exam. Here I given some miscellaneous questions that you have to do by yourself. See, these 6 questions you can do easily if you follow all the videos of this lecture series. 7 and 8 number questions are somewhat different. That I am going to do for you. First, I am going to solve this question number 7, that we have to find out the value of P if this equal to this. That means in your here, this is in decimal number system because base is 10, and this is any unknown number system, that is your P. We have to find out this P value. Okay, before I am going to solve this question, I am going to give you simple example. Suppose we have a binary number 1 1 0 0 and I am trying to convert it to decimal. You just recall how we are going to do, how we done at that time. You just recall, or you follow that book, follow that video. How this is your LSB, least significant bit. This is your leftmost, is your most significant bit. So we have to multiply 1 by 1. This is your least significant bit. 0 multiplied with 2 to the power 0. Then we have to consider this one. This bit value is your 0. 0 into 2 to the power 1. Each time the power of the 2 will be increased by 1. Then this 1 will be multiplied with 2 to the power 2. Then this one multiplied with 2 to the power 3. Power of the 2 each time increased by 1. Now we are going to add these values. This value, this value, this value. This value is how much? This value is how much? 8. 2 to the 3, 8. 2 to the 2, 4. This value is 0. This value is 0. Finally, we got answer is 12. That means if I am going to convert this one to decimal, the value will be 12. Right? So this is the procedure that converting a binary number to decimal. So from LSB to MSB, each time it is multiplied with a 2 to the power something, and that value is increases by 1. Here first it will be 2 to the power 0, then power is increased 1 1 1 up to 3 for this example. Okay. Now we are going to consider another example. Suppose we have a octal number. Suppose this is your octal number 15, and we have to convert it to decimal number. What we have to do? Here, this is the LSB. 5 multiplied with 8 to the power 0 plus MSB is your 1 multiplied with 1, 8 to the power 1. And we have to just add these values. It will be 8 plus 5, that is your 13. That means if we are going to convert this octal number to decimal, the value will be 13. Okay, you just convert this decimal to octal, you can find 15. So this is the procedure to convert any convert octal to decimal. Now suppose we have any unknown number system. Unknown number system. Suppose here 42. I am going to consider 42p. Unknown number system. If I am going to try to convert this number system to decimal, what I have to do? I have to multiply this least significant bit into p to the power 0. Then 4 will be multiplied with p to the power 1. That's it. Okay. So here this question will be here I am going to do the decimal number. It has been given 54, and if I am going to convert this 42 to decimal, then the value will be this much. 4 into p to the power 1 plus 2. These values will be add up. वो add हो जाएगा. तो अभी कितना होगा? 54 इक्वल टू Here 4p plus p to the power 0 is your 1 equal to 2. So that implies 4p equal to 52 हो जाएगा. That implies p equal to 13. Okay. So here for this question, the answer will be 54 decimal number system is equal to 42. 42 having the number system is 13. So base is 8. Here base is 8 is octal. Base is 2 binary. Base is 13. You can say 13. This is your conversion of decimal to 13 number system. Likewise, you can do this one. Here in question number 8, it has been given that 3b, which is in the hexadecimal number system, you have to convert to any unknown number system. So how you are going to do this? Here we have to convert this number, that is your 3b, which is in hexadecimal number system, converted to 35 having unknown number system, that is your p. We have to find out p. What we have to do? We have to convert this left hand side hexadecimal to decimal. Then we have to convert this one to decimal. Then we are going to solve. So here 3b given, which is in the hexadecimal number system. If we are going to convert to decimal, here this is your LSB and this is your MSB. LSB given as b, that means b will be multiplied with 16 to the power 0, then plus 3 will be multiplied with 16 to the power 1, which will be equal to 5 into p to the power 0 plus 3 into p to the power 1. That implies here 16 into 3, 48, plus here b is nothing but your, in your hexadecimal number system, b is nothing but 11. 11 into 16 to the power 0 is your 1, is equal to, this is your 3p plus p to the power 0 is 1, 5. So that implies 48 plus 11, this 5 will become this side, minus 5 equal to 3p. That implies 3p will be equal to how much here? So here this will be 48 minus 5, 43, 43 plus 11, 54. That implies p equal to 54 by 3 equal to 18. Therefore, this value 3b, which is in hexadecimal number system, is equal to 35 18 number system. Okay, so this will be the answer. Here I completed all the lectures of this lecture series, and I given these numericals for you that you have to do by yourself. These numericals, go through these lecture series. I'll upload the note. You just download the note and watch the videos, prepare for your exam. Thank you so much for watching this lecture series. Thank you.